Okay, so let's just forget everything you think you know about math for a minute. Seriously, it's not about boring calculations, I promise. It's actually more like a giant detective story. And today, we're going to go on a hunt for a secret code that's hidden right in front of us, a kind of pattern language that connects everything from, like, seashells to the phone in your hand. So you ready? Let's start cracking this case.
This quote right here, this is the big secret. It's the key to the whole thing. Forget the tedious calculations. Math, at its heart, is all about being a pattern detective, you know? It's about spotting the clues, figuring out the rules, and then, this is the most important part, understanding why. Why does the pattern even exist in the first place?
And I mean it when I say these patterns are everywhere. They're in the spiral of a seashell, they're in the beat of your favorite song, they're even in the bus schedule, believe it or not. So today we're going to learn how to see this hidden language. We are going to become pattern seekers.
All right, so every good detective story starts with the first clue, right? For us, that first clue is going to be number sequences. Just think of them as little secret messages, where each number is a hint about what's coming next.
So here are a few classic examples you've probably seen before. You've got your odd numbers, 1, 3, 5, 7. Easy enough, you're just adding 2 each time. Then we have square numbers, 1, 4, 9, 16. That's just 1 times 1, 2 times 2, 3 times 3, you get it. And then there are these things called triangular numbers. They might seem a little more mysterious right now, but we'll get to them. The point is, each one follows a simple, predictable rule, and our job as detectives is to figure out that rule.
But here's a thought. What if these numbers aren't just a list? What if they actually have a shape? I mean, what do these numbers look like? It sounds like a weird question, but sometimes visualizing a pattern, well, that can unlock a whole new way of understanding it.
Okay, check this out. This is our first big breakthrough. The reason they're called square numbers is, well, it's pretty straightforward. It's because they literally make perfect squares. You gotta love that, right? It's one of those awesome moments in math where the name tells you exactly what's going on.
Just look at this. 1 dot, well, it's just a dot. But 4 dots? Boom, a perfect 2 by 2 square. 9 dots, that makes a 3 by 3 square. 16 dots makes a 4 by 4. You see the pattern. It's suddenly so obvious, so crystal clear, the moment you can actually see it.
Okay, so if that's how it works for square numbers, what do you think is going on with our mysterious triangular numbers? Yep, you're probably way ahead of me. It's the exact same idea. They're called triangular numbers because they form, well, perfect, neat little triangles. So you start with 1 dot. Then you add a row of 2 dots underneath, and suddenly you have 3, which makes a little triangle. Then add a row of 3 dots, and you get 6, a bigger triangle. Add a row of 4, you get 10. You see how it works? Each time you're just tacking on a new, slightly longer bottom row to build a bigger and bigger triangle. Super simple when you see it that way, isn't it? Okay, so we've got these different patterns, right? Square numbers, triangular numbers, odd numbers. But this is where the detective story gets really good. Because sometimes, clues that seem totally unrelated, they connect in the most surprising and honestly, beautiful ways. And we've found a really, really cool one.
Let's just try a little experiment. Let's take that first sequence we talked about, the odd numbers, and let's just start adding them together, one after another. So the first odd number is 1. Fine. Now let's add the next one. 1 plus 3, that's 4. Okay. Now add the next one. 1 plus 3 plus 5, that equals 9. Let's do one more. Add 7 to that, and we get 16. Are you seeing what I'm seeing here?
Wait a minute. There it is. That's the big reveal. Those answers we're getting, 1, 4, 9, 16, that's not just some random list of numbers. That is exactly our sequence of squared numbers from the beginning. How cool is that? 2 patterns that seemed totally different are secretly connected.
But why? Why does this happen? Is it just some weird magic trick? This right here is the most important question in all of math. It's not enough to just spot a pattern. A real pattern seeker always wants to know why it works. And the beautiful thing is, in math, it's never magic. There's always a reason. And this picture, this picture explains it all perfectly. Look, you start with that one little dot in the middle. To make the next square, the 2 by 2, you add 3 dots around it in an L shape. See that? Now to get to the 3 by 3 square, you add 5 dots in another L shape around that. Every single time you add the next odd number, it forms this perfect new layer that builds the next biggest square. It's not magic, it's geometry. It's a visual proof right there.
Okay, so we've seen how numbers can have these hidden shapes inside them. So for our final clue, let's flip that around. Let's see how this whole pattern-seeking thing works when we start with the shapes themselves.
So let's look at a sequence of shapes. These are called regular polygons, which is just a fancy name for shapes where all the sides and angles are the same. We start with 3 sides, a triangle, then 4 sides, a square, then 5, a pentagon, then 6, a hexagon. You can see the pattern, right? It's super simple. We're just adding one more side each time. And here's the really cool part. This pattern of shapes, it's secretly being controlled by a simple pattern of numbers. The number of sides, 3, 4, 5, 6, that's just the basic counting numbers we learned as kids. It all comes back to numbers. It just goes to show you how everything in math is connected.
So you see, it doesn't matter if you're looking at a string of numbers or a bunch of shapes. The game is always the same. Find the rule, figure out the pattern, predict what's going to come next. That right there is the heart and soul of being a pattern seeker.
So we've cracked the case for today. But honestly, the real adventure is just getting started. Now that you're in on the secret, that math is all about finding patterns, I want you to keep your eyes open. Look around. What codes are hidden in the buildings you walk by every day, in the music you listen to, in the games you play? Now that you're a pattern seeker, what are you going to discover?